when it comes to factoring, over the years I have introduced factoring when the coefficient of the x squared term is 1 using these four problems: x squared plus 5x plus 6, x squared plus 5x minus 6, x squared minus 5x minus 6, and x squared minus 5x plus 6. All of these have the same numbers. The only difference between them is the signs. And I use these problems because I could point out what my Algebra 1 teacher said to us when we were first learning how to factor. Now, there have been many methods that have come along where they try to teach systematic ways of factoring, and I find that many of them are so tedious and take so long that I like to go back to the way Mr. Cosgrove taught us. And let's just talk about this for a second. If you have two quantities of binomials, and we're just doing the easiest ones where we just have an x, and you have some other constant term added to this, you only have like four possibilities. You could have a plus here, and a plus here, and then some number. I don't care what number it is. And then you could have two minuses and some number, x minus some number. Or you could have one of each. You could have x plus some number and x minus some number. Or you could have x minus some number times x plus some number. Now, if you think about it for a minute, these last two things are really the same, because theoretically, with addition, with multiplication being commutative, I'm not getting a, let me see if I can get a color one here. I'm using Smartboard that we use at school. If you think about it, these two are the same. It doesn't really matter if the plus 1 comes first or the minus 1. So really, these two have the same. You could always switch these two, and it would be the same multiplication. So we only have to consider one case. Now, if we multiply these two by the FOIL process, we're going to get an x squared. And we would do that with all of these. We would get an x squared and an x squared. When we did the last times last, a plus times a plus is going to be plus some number. A minus times a minus is going to be a plus some number. A plus times a minus is going to be minus some number. And in this case, when we did the outside, that's a plus number, and the inside is a plus number, you're going to have plus some number x in the middle. In this case, we would see that we'd have a minus x and another minus x, so those would add up to be negative some number x. And then in this case, you'd have a minus constant term, and the sign of what was in the middle for the x would depend on which of these numbers was larger, the positive or the negative. So the sign here would depend on the size, absolute value of the size of the numbers that are in these quantities. The one with the larger absolute value would control what the sign of the middle term was. So, what does this mean when we're going backwards? Let's see if I can't get rid of what we've just written here. Mr. Cosgrove, my Algebra 1 teacher, who, as far as I could see, my brothers both had them, and neither one of them majored in math, but they both learned how to factor perfectly and learned it and remembered it when they had to help their own children. So his method was pretty successful. I mean, I know that I remembered it, but I was teaching math all those years. Now, what Mr. Cosgrove said was that if there's a 1 here, which in these problems there are, you can actually, and I'm kind of adding to it, you can, this is my own phrase here, read what you need method. You can read what you need. Watch how I read this. I'm looking for two numbers, well, that multiply to give me 6. I know that I've got an x here and an x here. This is kind of tedious because the only way you're going to get an x squared, first times first, is an x and an x. And even in this last one, it's going to be an x and an x. And what's going to go here has to be two numbers that multiply to give you a 6. So I know that I'm after numbers whose, if I just think about their absolute values, I'm looking for two numbers that multiply to equal 6. Well, think about your times tables. That's 6 and 1 and 3 and 2. Only two sets of contestants. We are looking for two natural numbers whose, and Mr. Cosgrove said, pay attention to this number right here. If it's a plus, you're looking for numbers whose sum is the number in the middle here, 5, and whose product is 6. Let me erase that again and see whether we can make that clearer. When we want to factor these trinomials whose leading coefficient is 1, it's obvious that we are going to have an x times an x, and what we really need to find is this other set of numbers that are on the ends, and then we have to figure out the signs. So I'm going to assert here that we can actually read what we need if we read backwards. I'm looking for two numbers, two natural numbers whose product is 6 every time. Whose product is 6. So I'm going to put whose product is 6, whose product is 6, whose product is 6, and whose product is 6. Easy enough. The product, and let's think about the numbers whose product is 6. Well, that would be 3 times 2, or 2 times 3, and 6 times 1. In this case, that's our only options. Now I'm going to show you how you can read what you need. Mr. Cosgrove said that if this sign before the last term is positive, that means that the two quantities have to have the same sign. Because the only way you can get a plus is from a plus times a plus, or a minus times a minus. If you have a plus times a minus, this sign would be negative. So in this case, we're going to look for those natural numbers whose sum, because there's a plus there. Now right here, the only way that you can get a minus is if you have difference signs. So here we're looking for two natural numbers whose difference, whatever way we're going, is 5. In this case, whose sum is 5. Sum is 5. And whose product is 6. Whose difference is 5 and whose product is 6. Looking for two natural numbers whose difference, because of the minus, is 5 and whose product is 6. And we're looking for two natural numbers whose sum is sum, because of the plus, is 5 and whose product is 6. Now, as far as the signs go, Mr. Cosgrove said, if this is a plus, then just look next door, because you need to make sure that the middle terms multiply to give you a plus. So if this is plus, look next door, because they both have to be plus. Let's look at the other case where there's a plus down here. This says the signs have to be the same, and Mr. Cosgrove said, look next door. They must both be minus. Now, if this is a minus, then one must be plus and 1 must be minus. That says this, the signs are different. I usually put off putting which one is which until I see the size. They're different. But let's think about this. If I have this sentence whose sum is 5, well, 3 and 2 is 5. So this must be a 3, and this must be a 2, or this must be a 2, and that must be a 3. Because of commutative property, it doesn't really matter which one goes first. This problem is done. Same with the last one. Two numbers whose sum is 5 and whose product is 6. That would be 3 and 2. And this product, this factor is done. The ones that are harder are when they end in a minus. But let's see, whose difference is 5. That would be 6 and 1. I'm going to put 6 and 1 down in both of these, as I know those have to be the numbers. Now, I know that one of these quantities has to be plus and one of these has to be minus. And when I multiply the inside and outside, I'm going to get 6x and I'm going to get 1x. And I have to guarantee that this, with the signs being the way they should, that this must end with a plus 5. So who has to be the plus, the 6x or the 1x? Think about it. It has to be the 6, because it wins, and this has to be minus. In this case, the 6 would have to be negative, and the 1 plus. I hope you followed that. This is read what you need, looking for two numbers whose product is 6 and whose sum is 5 or whose difference is 5, is what these problems all say. We'll look at some other problems where there are different numbers and see if we can learn to read what we need to factor. Thanks. Bye. We're looking at the Howe-Two program Factoring Trinomials. It has a lot of submenus, so I'm going to pull it up here. See if I can't pull it over here where you can see it. There's, like I said, there are some methods that are compulsory by some schools. One is the AC factoring method, and I did take you through that, but I wanted to put in Mr. Cosgrove's as well. So there are various types of factoring, and teachers can decide to do them one at a time and add to your repertoire, get good at each of the types of factoring. But the one we're going to look at is easy factoring, where the coefficient of the leading term is 1. So I'm going to come to that program now. And let's see if I can't bring it over so you can see it. You can go back into the other types if you're required to do that. And I also have a marker down here which I hope is going to be accessible. So, okay. All right, so we're going to look at this. Let's look at this problem, x squared plus 7x minus 18. I've said that you can read what you need. I'm going to read it to you here. I am looking for two numbers. I might as well bring up the marker here. Two numbers whose product is 18. 18 product. Now this is kind of a hard one because there's lots of things that gives you 18. But now I'm going to read and whose difference is 7. So product is 18 and whose difference is 7. This should be enough clues for me to figure out what each of these quantities has to be. This has to be an x and an x. Like Mr. Cosgrove said, you couldn't end up with a negative here unless one of these was plus and one was minus. So let's think about the things that multiply to give us 18. Well, there's 18 and 1. Their difference is 17. That can't be the one. There's 9 and 2. Oh, their difference is 7. They must be the winning combination. So it must be 9 and 2. I don't have to strain my brain anymore. I've already thought of the pair. There's going to only be one pair whose product is this and whose difference is going to be 7. So I know it's 9 and 2. Now I know there's either plus 9 and minus 2, or there's minus 9 and plus 2. And all I have to decide is which quantity gets the plus and which quantity gets the minus, because they have to be different. Now, in my mind, it's sort of like a contest, a beauty contest. We know that the 7 has to be positive. That means the positives have to win. So, which of these two numbers has to have the stronger absolute value? Would be the one that gets the plus. So it must be x plus 9 and x minus 2. Hope you followed that. I'm going to minimize this now and then put that in. X plus 9 and x minus 2. When you go to the left, you get the negatives. When you go to the right, you get the positives. It would count it correct if you said x minus 2 and x plus 9, because multiplication is commutative. It wouldn't matter which quantity goes first. Check, we win. Let's do another problem. Oh, couldn't get easier. This time we are after, I hate to even insult you by reading it, two numbers whose product is 6. What is that? 3 times 2 and 6 times 1, and whose difference is 1. Only the difference between these is 5, so the difference, it's got to be 3 and 2. And there has to be an x and an x. And this time, in the battle for the middle sign, the negatives have to win. So the number here with the strongest absolute value has to have the negative attached to it. That would be the 3. So we have x minus 3 and x plus 2. Easy, isn't it? X minus 3 and x plus 2. We're going to win again. Now, a lot of times in calculus, trinomials like this come up in problems, and those students who rely on the more complicated methods, they spend 15 minutes factoring when they could just read what they need. So on these easy ones, I suggest that you learn the read what you need method. New problem. I'm looking for two numbers that multiply to give us 18. That would be 9 and 2. I got to get a marker there. 9 and 2, 6 and 3, and I guess that's it. And whose product is 18 and whose difference is 3. It must be x and x, and the signs have to be different. So it's 6 and 3. In the battle for the middle sign, the negatives have to win. So the 6 would be negative and the 3 would be positive. And if we minimize, we can put x minus 6 and x plus 3. Now, if I were doing this for a test, I would make sure by foiling to make sure that I got the problem back. That way, when you turn in your paper, you can be absolutely sure that you're going to get 100. First times first, x squared outside, plus 3x inside, minus 6x, grand total, minus 3x. Last times last, negative 6 times positive 3, negative 18. We win. This time, oh, we've got a plus. Life is easy. We know this time, but the signs have to be right off, because if this is a plus, we use Mr. Cosgrove's trick and say, we're looking next door. We know they both have to be plus, or this could not happen. We're looking for two numbers that multiply to give us 33 and add to give us 14. 11 and 3. They do add to give us 14. 11 and 3. Let's see. 11 and 3. Check, we win. Oh, this one's awful. Too big of a number. I don't like it much. But we can do it. Let's think of 108. Let's bring this up. We need two numbers who multiply to give us 108 and subtract to give us 3. They've got to be pretty close together, the two factors, so it can't be 108 and 1. That's just too far off. So we need to see what's in here. Let's see if they were 10 and 10. This is divisible by 9 because the digits add up to 9. I bet you 10 times 10 would give us 100, and they'd be 0 apart. But let's see, this is not 10 times 10, but I can see that it's divisible by 9. So I'm going to guess, let's see, 9 into 108 and find out what the other factor is. 9 goes into 10 once. 18, it looks like it's 12. Oh my goodness, 9 times 12 gives me 108. And are they 3 apart? We found the winners. So it has to be x and x, 12 and 9. The signs must be different. One of these must be plus and one of them must be minus. But in the battle for the sign of the middle term, the negatives have to win, which means that the larger number here has to be negative and the other one positive. Let's see, x minus 12. I'm pushing minimize, so now I can answer. And 9. And we win. Hope you're getting the idea. Read what you need is kind of easy. Oh my goodness, you're going to get to the place where you're saying that this is too easy. We could try this on some other problems that don't have a 1 in front of them. Oh, let's see if we can't find that. It's not too bad. I'm going to try this one. I can't use the complete read what I need, but I can use the information about the signs. So right here, this plus tells me to look next door. I know that both of these quantities have to be minus. And there has to be an x in here and an x in here. But let's see, 3x squared. 3x squared. There's not a lot of choices there. One of them has to be 3, and then one of them has to be 1, because there's only one combination that can give me 3. So the question is, what goes here and here? Now this time I'm not looking for factors of 4 that give me 8 when they add, because I have to take into account this 3. So here we had the choices of 3 and 1 over on this side, and we have 2 choices for getting the 4. 4 and 1, and 2 and 2. Now I usually tell students to stare at these choices. The 3 has to, I'll start again. One of these 2 pairs has to be the one we're after. And we know that the 3 times 1 is the pair we're after because it's the only one. But one number over here has to multiply one of the numbers in the correct pair over here, and then the other one has to multiply the other one. And we're going to have to add to get 8. So if I imagine 3 times 4 is 12, that's already over 8. So at 3, it can't be that. It could be that the 1 multiplied the 4, and the 3 multiplied the 1. That would give me 7. No. How about if the 3 multiplied the 2? That would be 6. And the 1 multiplied the 2. That'd be 2. That would give me the 8 I need. So it's not this pair. It's got to be 2 and 2. So I double check. 3 times x is 3x squared. Outside is minus 6x. Inside is minus 2x. And last times last is plus 4. It's going to add up to the right thing. So I'm going to minimize now and put in 3x minus 2 and x minus 2. To get 3x, I'm going to click in the white space. 3x. Oh, I guess I got to go this way. 3x. Nope. 3x minus 2 and x minus 2. Let me double check. First times first, 3x squared. Outside, minus 6x. Inside, minus 2x. Grand total, minus 8x. Negative 2 times negative 2 plus 4. We win. Watch the guy, the professor. He's going to be happy. That is correct. So we got that one right. I'll do one more that's, maybe we'll try to find one. That one is plus, so the signs will be the same. Let's try to work one. Let's try this one. The only way we can get the 5 is with a 5x and an x. The only way we can get the 5 is with the 5 and a 1. The only way we can get the 14 is 14 and 1 and 7 and 2. And we want to, somebody over here has to multiply somebody over here, and we have to end up with a 3 in the middle by subtraction. So I usually stare at these numbers, and there are only so many possibilities. You can actually put them all down and try. That's really the process of elimination. That's what all the other systematic ways end up having you do. But if you can use your intuition, I can see right now that if the 5 multiplied the 2, that would give me a 10, and the 1 multiplied the 7, and I would subtract to get a 3. So I'm thinking that it's not 14 and 1, it's 7 and 2. And I've got to make sure that the 5 ends up multiplying the 2. So 5 to multiply the 2 would have to be here, and the 7 would have to be here. This would give me 7x, and this would give me 10x. And I want to rig the signs so that they're different, but we end up with a plus 3 in the middle. So the 10 would have to be plus. I used to say to myself, the 10 has to be plus. So it flies through the air with the greatest of ease. The 10 has to be plus, so this has to be plus. And this one would have to be minus. And we would end up with a plus 3x. So 5x minus 7 and x plus 2. Let's see if I can remember that long. 5x minus 7 and x plus 2. Let's see, one more check. 7x and 10x minus 7x plus 10x. It's the 3 in the middle. Check. We win. That is correct. Hope you get the idea how the signs can help you. I usually put my options for the first term over here and the options for the end term over here, and just try to think until I can get the right thing in the middle. So maybe you too could learn to factor using Mr. Cosgrove's method. It worked. But we have the other methods as well, which we will have to go over, or maybe your teacher will go over. The program's kind of complicated. This is easier.